Hello everyone, thanks for coming. Now we will learn about the use of tracer modeling to give a signature to our gas cap gas and gas cap oil. And we will learn using the sample case from tNavigator. Hopefully our learning today will be very much useful for all of us. Okay, so we are currently looking at the model to the pressure map, and then we can go to saturation of oil map, water, gas, and 3D view. And interestingly, we can also look at the saturation ternary diagram. Okay, so the red color shows the gas. We can call it our gas cap. The the green one is our oil rim. And lastly, this one is our H water. Okay, water leg, the blue color. Okay, so we will put a tracer on our gas cap gas and gas cap oil so that later on during the simulation we can track their their pathway, okay, from the gas cap zone to all right to other area, maybe to a particular producer, maybe to P2 or maybe to P1. We can follow the movement of our gas cap gas and our gas cap oil because we put tracer on them. All right, so you see, based on the distance itself, visually we can say that producer 2 is located close to the gas cap, all right, compared to producer 1. But ultimately during production, they will of course, you know, produce the gas cap gas and gas cap oil, and later we will check the production profile. Okay, but before that we need to put the tracer first, and we can do that. But before that, I will show you the file itself. So regarding the file, there is nothing special here. Run spec, start, metric, unifault. We have dissolved gas and vaporized oil. All right, nothing special here, but later on we will put some keywords. We have one Satnam region, one PVT region, one equilibration region, one Vipnam region. Nothing so special, right? Okay, so now we will first indicate our gas cap. And let's say we know the location of our gas oil contact. Maybe you talk with your friend, the geologist, and you know the gas cap or the gas oil contact or the water oil contact. You must know about that. And let's go to user cut. Okay. And then we put here. Let's say we know that the depth of the GOC, gas oil contact, is at 1816. So we will cut our model. So I want to know area before this depth. Okay, area that is shallower than this depth, which means the area will be our gas cap. So we click on apply to cut. Here we get the color. So because we put or we use arithmetic command line here, the true, the area or the grid that meets this criteria will be valued 1 and color thread like this. So we can say that this is our, this is our gas cap. Okay, and then we put our tracer on this area. How do we do that? We, here, right click and then export. We will create map of this area. And then after export, file type save 3D, okay, because everything will be in 3D. And we will call this area with a certain keyword. And let's say the keyword is here, TBLK. So T for tracer, BLK for, I think it's for block. And then F, okay, and then GC is for the gas cap, and big G, this is to denote the gas, okay. And okay, actually this is the keyword that will be used in the tNavigator. And to make life easier, let's just rename our .map like the keyword. So I will paste here, okay, and it will be saved here in this folder, okay, within the same folder as the location of your simulation file. So the name, so I will create a file which is .map, okay, .map, and the name is gascap model underscore tblkf gcg, okay, to note that this is my gascap zone, and I want to, this is for the gas in our gas cap on which we will put tracer, okay. All right, so it will be the initial concentration of the tracer, and the tracer is in this case the gas of the gas cap, okay, and the value will be 1 here, okay. So I can click on OK here. So I already create a map, and in that map I have the information of the initial concentration of my first tracer, and my first tracer is the gas in gas cap, okay. I'm sorry for if it is a little bit complicated, then yeah, maybe you can do it by yourself by looking at my video as well, okay. By the way, to indicate gas cap, you do not always need to use this Z below this value, but you can also use, for example, gas saturation greater than something, okay. If you are very sure that at that saturation point it is for the gas cap, okay. Like for example, as gas greater than 0. You know 3, for example, we can apply, or maybe as gas greater than 0.1, or maybe 0.001, like this. Okay, and let's say 9, so nothing greater than 0.9, 0.5, yeah, something like this. So if you're sure that the gas saturation in your gas cap is greater than some value, a value, then you can use that for the command line. But I'm going to go back to this one. Okay, so that's the first thing. And then we also want to make other tracer. And in this case, the tracer is the gas, but from outside the gas cap. Okay, that's our second tracer. The first tracer is the gas in the gas cap. The second tracer is the gas outside the gas cap, which means all gas except the gas cap gas, like free gas, and dissolved gas dissolved in oil. Okay, and we will create, to make that, we will create another user cut 1 here, and then of course the area outside the gas cap will be Z, the depth greater than 1816. This is the area below the gas oil contact, and then apply to cut. Okay, so this zone, this area will be valued 1. So that will be the initial concentration of our gas outside the gas cap. Okay. And yeah, you can also go back to 2D map, but of course 3D map will be more helpful here. And again, we will export. Okay, and then yeah, for the keyword, we will use tblk. Okay, this is for tracer blk for, I think it's for block, but if you are not so sure, you can go and read the tNavigator manual. And I'm not so sure about F. Okay, but yeah, in this case, we need to use F, and we use or G here. Okay, so the value will be 1, and the area of the gas cap will be valued 0, and this area below or outside the gas cap will be valued 1. Okay, the value will be 1, and 1 will be the initial concentration of that second tracer, and the second tracer is the gas outside the gas cap. It includes free gas and gas dissolved in oil. And to simplify, we can also copy and rename our file using that name. Click on OK. So we have already 2 tracers. Okay, but don't forget, actually we will have 4 tracers because in gas cap, the gas is not alone. Okay, in the gas cap, we also have oil. Okay, so in the gas cap, we have 2 tracers, gas, the gas of the gas cap and oil within the gas cap. And on the same way, okay, the area outside the gas cap will also have 2 tracers. This is the gas outside the gas cap and the original oil outside the gas cap. Okay, and yeah, that's for the preparation. And now we will modify our master data. We will first put the keyword tracer here, okay, in the run spec section. And the keyword is here, tracers with S. All right, make sure you use S there. And then we put slash below. And then go to props. In props, we will have another keyword for tracer. We put it here. And this keyword is trace without S. Okay, and then the first one is I will make a note first, GRG or GCG. Okay, this is for the free gas in gas cap. And the keyword is G or big G, and the phase will be gas, and then close with slash. Okay, so that's the keyword. This is for the gas cap gas. It should be G. And then the second node is GCO, big O, and it's the vaporized, oil in gas cap. And the keyword is GCO, and the phase will be oil. And the second tracer, the third tracer is ORG. Okay, it is the gas in oil rim. Okay, either free or dissolved. All right, and then the keyword will be ORG, and the phase will be gas because this is the gas in oil rim. And lastly, our fourth tracer is the ORG, or sorry, ORO. It's the oil in oil rim, free and vaporized in gas. Okay, and then the keyword is OR big O oil, close with slash, and close the tracer keyword with slash. Okay, I hope there is no typo. And then let's save. Okay, and the rest actually is simple, nothing so special. And then we need to copy our maps. Okay, so previously we have created two maps for our two tracers, which is gas in the gas cap and gas outside the gas cap. We will copy them and make exactly the same for oil in gas cap and oil in oil rim. So let's go to our file. Okay, so this is our file. And yeah, this is GCG is for the gas cap, the gas in the gas cap. We will copy and just paste and rename them as GCO like this. And on the same way, this is for the gas of the oil rim. We just copy and change it to or rename it to or O to denote the oil of the oil rim. Okay, so and of course they will be included in in the include file. So let's cut and then put them in the include folder. Okay, and then let's go to our simulation or user interface. Okay, and then we need to put the location of our maps within the solution. Okay, so here we have the solution. I will put that, yeah. So I already type in the name. So yeah, it's here. Okay, so I put that in include folder. So tNavigator will take this, will take this file to be included in the solutions section. Okay, and then don't forget to click save, close, and then we can, of course, reload to make the simulation or the modeling ready. Okay, so we will reload. All right. Okay, so we have reloaded and let's check the calculated. Here we have new tree, which is called ASP flood and tracers. So this is for our tracers. And you see we have four tracer. The first one is the gas of the gas cap, GCG, and then the oil in the gas cap, GCO, and then the gas in the oil rim, ORG, and the gas in the oil rim, ORO. Initial concentration, 1 for the gas of the gas cap. All right. There is no gas initially. Okay, in the gas cap, there is no oil, I mean. And then this is the gas in oil rim. And then oil in oil rim. Or I think we made a mistake because the GCO, we should find value of 1 in GCO because we just copy GCO from GCG, right? And the same thing with ORG, it should be the same with ORO. So let's go back to the files. Okay, and then here, so I'm going to delete it and then copy and then paste and then rename it as GCO. Okay, and then for this one should be ORO. Okay, and yep, we can go back to the user interface. and then again we will reload. All right, so this one and then reload. Okay, so the problem is not yet solved. And I think there is a problem with the keyword. So let's go to files and then let's find the solution. All right, here. So we have problem with GCO. Let's open it. All right, so this is the problem. Okay, because the keyword within this file is still GCG. It should be GCO. All right, be careful there, GCO. So we already edit the file. This is GCO map and the keyword should be GCO. And then of course we go back to the solution and then let's find the, I think it's ORO. And yeah, I will maximize and let's just change it to ORO and then control save. Easy, and let's reload it. Okay, so we have done the reloading. Let's check at the calculation, add tracer. Okay, 1 in the gas cap for GCG. And what about GCO? All right. Okay, so there is only a keyword issue. It's normal to occur during your simulation. All right, so don't be scared. So gas in oil rim. Okay, we have gas and the concentration or initial concentration is 1, and the same for the oil in oil rim. Okay, let's go to 3D. And what else after this? Of course, we want to, you know, we want to do the simulation. So let's just click on run, but I want to look at the GCG, and let's remember this, this distribution. There must be changes after we run the simulation. Okay, so we have started the simulation. It's calculating. Of course, there will be distribution of our tracer, and again in this case the tracer is the gas cap gas and oil in the gas cap, you see. So very quickly the gas and the oil breaks through into this, I think it's P2, and need more time for P1 because the distance, is farther. And during this calculation we can go to graphs. Yeah, you can get the rate, but the thing that I want to show you is the tracer here. Uncheck everything. You can monitor here. So let's see the P2, uncheck everything, and then open the tree for the gas cap gas production. So you see, this is the production of the gas cap gas by the P2. You see the trend increases very quickly, which gives the indication of, the breakthrough of the gas cap gas into P2. And what about the oil? The same, very, very quickly. It's premature breakthrough. Yeah, because the location is very close from the well to the gas cap. Okay, maybe the engineer want to produce the gas cap. I don't know. So this is for the P2, and what about for P1? Okay, so for P1, oil comes first. Okay, the red color. And then the gas cap gas comes at around January 2014. Okay, and what about the oil? or gas from the oil rim for P1? Of course, the gas from the oil rim and the oil from the oil rim will be readily produced by P1 because P1 is located at the oil rim. And of course, the same way with P2. Very early in the initial time of the production, readily the oil and the gas from the oil rim are produced by the wells, by the two wells. Okay, you see here, very easy, right? And yeah, maybe we can right click and then create custom palette fast and then custom palette setting logarithmic to give us more detail for small value, right? For small value, we want to make it more detailed, we can use logarithmic scale. So it's like this. Okay. And of course, don't forget to use the tracer profile here, either for production rate, injection rate. If you use gas injector, water injector, CO2 injector, you can use this. And this is for the black oil case. And hopefully we can also discuss about compositional case. In compositional, we will now talk about oil, water, or oil or gas, but we will use the name of the component itself, either C1 or CO2 or maybe nitrogen. Okay, but for now, I think we can close. This is the learning for the use of tracer for our gas cap or oil rim. Okay, so I hope you enjoyed this video. I hope this video is useful. Thank you so much for watching and see you again in the next tNavigator videos. Thank you.